covering a lot of ground here. Week 6, 218. Database and SQL. We talked a little bit about learning, how important it is to see your own results. We corrected exam. Did practice 5, relationships in SQL. Then we went down and set up the STEM room for a meeting. And it was a lot of help. The students did a nice job. Relational types, one-to-one, one-to-many, many-to-many. We're going to talk a lot about that all the way until the end of the term. Okay, we talked about attributes, constraints, so the type of attribute and what kind of constraints. We can have cardinality constraints, which these over here, and we can have other type of constraints. You can have a certain domain that you pick from. An example would be if you were connecting, we used a lot of times this U.S. states table, and then maybe we had a student, student table, and the student table would reference the United States table for more information, like to get the area or what region they're from. Okay, so this could have a constraint, okay, that it has to come, it has to match and come from this table. I'll talk a lot about that more later on. And in the United States, you could have a constraint on a field. Alright, so I had a little glitch there, but anyway, yeah, in the United States, this table here, or this, could have a constraint where it's only 2 characters, and it has to come from this table. So this IO wouldn't work. Alright, we'll keep going. I've got some markings here already, but the recording had stopped, so I'll just talk through these briefly. I am going to use a blue to highlight these. Okay, so we have student, first name, if you see where I'm at. We've got a select statement, and so we've got a student dot first name, and there could be more fields, more qualified fields, and then we have our 2 tables. This is a country one, and then where, now we have a join. This is a simple join, but we're saying the CID from the student table has to match the rank from the countries table. So this is the foreign key has to match that primary key in the other table. And you can see the example down here. Okay, we've got the foreign key has to match the primary key in the other table. It's a one-to-one relationship, and there's a constraint. If you try to enter a number in here that isn't already here, it won't let you do it. It will let you enter a null. More or less, you have a student who hasn't been assigned a country yet to be an exchange student at. So here is some more information that we worked on in terms of the pitching problem. The predictive pitching problem. Predictive pitching problem. Anyway, so we have pitching, we have the counts, we have pitches, batting, location, players. Here in a little bit we're going to look at this more specifically. Okay, but this was a step in trying to work our way to a diagram that would give us more specifics so we could actually create the tables. More of that coming up. Here's an example where we have the United States, we have the abbreviation, we have students, and we have state, like Iowa, and we have a relationship. Now, in this case, we said a student can only have residence in one state. Now you say, no, you can do that differently. Well, I don't know for sure, but that's how it's set up. But the states can have many students. We'll use an M or an N. It doesn't make a difference to me. There's some details there we're not going to get into right now. Okay? And so we talked about players, batting, or at bat. Again, this was some ideas, and we have more specifics moving forward. Here, week 7, and we talked about on Friday we had an Unreal Engine demonstration which helped us understand object-oriented programming. I talked a little about AWS and some options we might have combining with them, and then we talked about softball a little more, the pitching location, batters. And on Saturday, the students participated in the cyber defense competition. They didn't advance, but they did really well. Okay? Database and SQL. Leading up to spring break, data modeling, exam, relationships, midterm, and SPA. Some of the midterm now we're finishing actually up this week, and we did the SPA before spring break. Entity relations, dataship, the relationships. So this is now a nice preview of looking at, we have users. Oops. Let's see if I can get this. Okay. We have users who have a view of the data. They can see it through their browser or through an app. There are other ways, but those are the primary ways that we are working with. So in our conceptual view, how do we view it? We start to form entities. You're starting your individual projects, forming entities. Then you figure out what attributes describe the entity, decide what type those are, and then we create base tables. That makes sense? The type, now here we're talking about, is it text? If it is, how big a text? You know, for example, in the state situation, it could be 2 characters. A phone number could be a certain number of characters. Is it numeric? And if it is it an integer or float or whatever? Is it a date, which is really like a number, but so those are the primary types that we use, and there's a wide range of variants within those. Moved from the conceptual to the physical, start actually, once we get all this determined, we can actually start building some tables. And then we'll use MySQL to actually write the data to the hard drive and get it back off where it's stored. Here's a little bit of an ER diagram. I took the mandatory part off there. One client can rent many devices. Do you see that? One client can rent many devices, or a device can only be rented by one client. Right? Okay, you can't have a device rented by 2 people. It has to be one. And in this case, you can see here's a primary field. It's underlined. Here's a foreign key, and it has the dots underneath them. Okay? Primary keys. I just happen to use red to represent them. We're over halfway, believe it or not. Here is the same example with the, let me pick another color here. I'm going to actually use black. We have the clients, the devices, and then the weak entity rentals, because it's dependent upon these two base tables. And if you just look at the reference between devices and rentals, you know, 1 to 1. One device can only be in the rental table once. 1 to many, we can have a client be in this table multiple times because they can rent multiple devices. So we have this 1 to many cardinality relationship, or constraint, we call it. Okay? And you can compare this. I'm going to take that mandatory out of there. And you can compare this to our diagram over here. You would need to understand your relationships before you move forward to actually start creating your tables. Get another example of that coming up. This is the same thing, right? You can see primary key to foreign key, primary key to foreign key, primary key to foreign key. 1 to 1, 1 to many. Okay, this is today. Okay, we are now after spring break. We're on week 9 of 15. Okay. Approximately day 16. I think that's about right. We had a lot of snow days, so we didn't meet all 16 days. We started off today, talk a little bit about learning. Tatanka Savings Bank. We talked a little bit about banks there. I'm looking for an intern this term and maybe this summer. So there's some opportunities there. You need to contact me. Then we talked about banking, their online services, maybe outsource some of that. Internally, they have lots of servers and so forth internally. And then they have remote, maybe VPNs or other ways in which they connect their banks. However they might do that. I believe they have banks in 3 different towns. Forest City, Tatanka, and I forget the other one. Okay. Midterm, you need to set up a time to take that. We're a little behind there, but no notes, and we glanced through it today. SQL. Check the solution for the skills-based. Let me know if there's questions. And we did some more on ER diagrams. So, in designing a database, we do analysis. You really want to create a conceptual view. So you want the concept of what you want to do. This should lead you to identify the entities and start thinking about the attributes that characterize the entity. From there we get a logical view and we build an entity relationship, and then we can start thinking about creating some tables. So we do an analysis, make sure we understand the problem, then we start designing it, and once we get far enough in the design, you have 1 or 2 routes. You can keep designing until you have everything perfect and the analysis perfect, and then start development. Or we're doing the agile. We're going to create a prototype. We're going to start creating some tables and fit them together and see what it looks like. Okay? And then if something isn't right, we iterate and reanalyze and redesign and keep developing a prototype until we get to the point where we think we have something that might be usable. This table goes with the next information. We have, this is a pitching project. We have the throws, who the pitcher is, the count, what kind of pitch, the location, and then the results, whatever that might be. So then we'll build this table up that eventually will have all these different counts followed by the pitch that was thrown based on the count and where the pitch went. So we can do some, once we build our data here, then we can do some analytics with it, which will be fun. It'll be fun. It'll be fun for me. I don't know about students. We pulled up this example. This is the example from the classwork database. That's on work server 1, right? Classwork, and we had these two tables. We got countries. It's got a longer name than that, but that's, we have countries, and then we made this student table. I think it's MD16, student ID, and then we built this relationship. Right, we've got a primary key here and a foreign key here, and in our scenario we said students, a country can have many students as exchange, but a student can only do an exchange in one country. At least that's the relationship we set up, or the way we were thinking about it. Okay? So this is an ER diagram. Entity relationship diagram. Now in our next slide, we talked about work server 2. Here is the local address, the public address, and here's how to log in. Last name, first initial, middle initial. And the current password IT Spring 2019 exclamation point. Then there's a document here that helps you get ready to prepare for your individual project. So first thing you need to do is analysis. You know, think about what you're going to do and maybe start thinking about, understand what kind of project you want to do. Make sure you understand it. If you need some help picking something to do, let me know. There's a couple general logins. Here's one from the past. I think it still works. It should. And our current one, if you want to just use a general login, it's class 2019 with this password. But you'll want to be logging in with your account so we can add information to your account. 2 pages. Look at this diagram. This isn't complete, but what we did, let me run through this, we created a base table called batters, right? And primary key in one of the attributes. Another base table, pitches, primary key, another attribute or field name. Location, primary key, location type, pitcher ID, these are actually the pitchers, again a base table, they have name and probably, I don't know, some other attributes there. Results, base table, so we've got result ID, result types, you know, they hit by pitch, walk, got a hit, maybe a hit on an air, you know, whatever, we can list wherever we want there. Count, okay, we have count ID and the count type, and I have those all listed in some documentation. And then this all ties together, and this isn't complete, with throws. Throws, you notice, is a weak entity. It's dependent upon all these other entities. Throw ID, okay, so we'll just keep a count of how many throws we record. We're calling them throws to keep away from duplicating terms with the term pitch or pitches. But a throw would be a pitch. But I didn't want to use the same word because we have pitches and we have pitchers and then we have their throw. So this would have lots of foreign keys. Does that make sense? Right. With each throw, we would have a as an example, we would have a pitcher. With each throw, we'd have a count with each throw, and you can see, you could go all the way around here's actually pitcher, that's the actual pitch. So we'd have all those foreign keys. And some type of relationship between these base tables. So then, as an example, over here, let me use another color there. This is what the table would look like being represented here. We're going to create this table together in class. Zach is going to create these two tables. Kevin's going to create this table. Chris is going to create this table. Michael, this table. And Drew, this table. Okay. And we created, it's actually called NIAC pitching. And it's on 85, and I gave these students access to it. So, we're ready to get going on the project. On Wednesday, we will create this table with some constraints to all these base tables. That is it for now. I should mention again, let me just reemphasize. We called it NIAC, I think, underscore pitching. Something like that. I think it's like that, NIAC pitching. So that's the name of the database. All the students should have access to it. So we're going to start creating our tables so then we can start testing. That is it. Thank goodness.